Hello friends. In this video we are going to learn how to make our C++ code more readable and expressive using structured binding. We are going to look at some code and really think and understand how structured bindings work. We are going to dive into multiple C++ code examples and understand how structured bindings work and what happens, behind the scenes in memory. So without any further ado, let's dive into it. Alright, so let's look at this example here, right? Let's start by creating a really simple function that creates and returns a standard pair, right? So the function returns a pair of, let's say, string and int. Let's call it make person. The function takes in the name of the person and his age. Let's create the pair. Let's call it person. Use the name and age to create the pair, and let's just return it. Right, so really simple function called make person takes in the name and the age of the person, makes a pair and returns it. Let's call this function in the main, right? So let's use auto result make person, and let's call this person Dave. Let's say he's 31 years old, and let's also print it to the console, right? And the way you do that with pairs is you get to use the first and the second members, which are public, right? So let's add some cout here for name, and if you do result dot first, you will access the name of the person, and if for age you can simply do result dot second, right? Let's run this. Okay, we did everything right. We can see that the name of the person is Dev, age is 31, right? So with this code here, right, you can see that to unpack the pair and access its elements, we use the first and the second members on it. Well, it does the job, but the question is, does it make the code more readable, right? And this result.first and result.second is kind of vague, right? And I don't think so that it makes the code readable. And this is where structured binding really helps, right? So on line 16, we can simply do this by using square brackets, and inside the square brackets we need to provide the exact number of identifiers or variables, comma separated. So let's call them m underscore name and m underscore age. Now if instead of this we can simply use the m underscore name and m underscore age, and if I run this, you should see the same behavior, right? Isn't this beautiful? So what's happening here? Behind the scenes, the structured binding declaration on line 16, right, has introduced a new unique variable to hold the value of the initializer, so whatever is on the right. And in this case, because we are not using a reference, which we'll get into later, we ended up making a copy of the pair, right? So this holds like the copy of the pair, and you get that way you get to access the name and the age of the person. So you can do a bit more, like there's additional elements to your structured binding. So let me start by putting the signature, right, of structured binding and how it looks. So this is like the exact signature of structured binding, and if you look it up in the official C++ documentation, you will see something like this, right? Now there's something called attribute, right? This is nothing but the attribute specifiers that you have in C++, and those are kind of optional, but just for example I'll use the one that I know, which is maybe, I think maybe unused. And what this basically does is it suppresses the compiler warnings on any unused variables. So it's not that important here, but just for example, I'm kind of showing it. And you can also, instead of making a copy, you can also use a reference here. uh, Depending on your use case, you can also use R value references. Those should also work, right? But here let's keep the copy, and instead of equal to, you can also use curly braces. So this will also happily work, right? You shouldn't see any change in behavior. And you can also use parentheses. They should also work. And just for completeness, I'll use a reference here as well. But I guess because we use a reference, I think we'll have to make this const, right? Otherwise we can't bind like an L value to an R value. So if I run this, you should have same behavior. But if I remove const, I think we should see a compiler warning, or sorry, an error, right? So cannot bind non-const L value reference of type this to an R value. Correct, right? So this is an R value, and we are kind of trying to bind an R value to a non-const L value. So if I simply add const here, I think the error should go away, but the behavior should remain the same. Alright, so let's look at another example. In this case, let's create like a simple function that returns a tuple of 3 elements. So let's say the tuple is made up of string, int, and a double. Let's call this function make person, and let's pass in the name, age, and weight of a person, right? Let's make the tuple int double, and let's call this person, and let's use the parameters that are passed to this function. Let's simply return the tuple, right? So we have a really simple function here called make person, takes in the name, age, and weight of the person, creates a tuple, and returns it, right? Let's actually call this function in main. So auto result, let's call make person. Let's say the name of the person is Tom. Let's say he's 29, and let's say he's 177.65 lbs. Right now, this is a tuple, right? And the way you get elements of tuple is by using something called standard get, right? It's a templated thing, and you kind of access its element using the right index. So let's pull out, let's use auto. Let's pull out the name from the tuple. So standard get zeroth element will be the name, and let's pass in the result, right? Let's do the same thing for age and weight, right? And let's print this all to console. So let's print the name first. Let's put a space in between. Let's print the age. Let's put a space in between. And finally, let's print the weight. Hopefully this compiles and runs. Fantastic. So we see the output. Tom is the name of the person, 29 is his age, and 177.65 is his weight. So as you can see, right, to access the elements of the tuple, there's a lot of code that we have to write, right? And this is where your structured bindings really help you, right? We can replace all of this code by simply doing by simply using structured bindings, right? And as we saw in the example, in the first example, we can simply use square brackets. We can then provide the right exact number of variables, right? So we need the name, age, and weight. And then if you run this, you should see this exact same behavior. So as you can see, right, the structured bindings really help here in making the code more readable, and it also makes the code way shorter. And if you're working with large code bases, right, lines of code is a very important metric which you have to always keep in mind, right? The less lines of code you have, the better it is from a code maintainability perspective. All right, so let's look at one last example for structured binding, right? And in this case, what we'll do is we'll create a function that simply takes in a standard map and prints it, right? So let's create a function. It won't return anything, and let's call it print. Let's pass it in a map, and the key, let's say it's a string, and value is an int. Let's call it map to print, and let's simply print the map, each key value pair in the map, right? One way to do that is you can use const auto ref, and simply this will simply go over the map one at a time, and you can extract the key using kv.first, and in a similar fashion you can extract the value as well, right, using kv.second. Let's print the key values to the console. So let's add a cout here, key, and let's also print the value. Right, let's call this function from the main, say print. Let's make a map of this type, right? Let's say we have 3 key value pairs in it. Let's say the first one dev, and his age, let's say it's 29. We have a Tom in there, say 32, and let's put a Jane in there, 44, right? And let's pass this map to our function. Let's run this. Hopefully, yes, it works. So simple function that takes in a map and prints the key value pairs. Now you can see that we have a bit of an extra code, right? Let's call this extra for a moment. We can replace all of this code by simply making use of structured bindings, right? And if you remember from earlier examples, all we need to do is have a square bracket and add the exact number of identifiers or variables to it. So let's make use of structured bindings here, right? So if I simply use square brackets, key comma value, and then I can get rid of all this code, right? And then if I run this, it should have the exact same behavior as we saw earlier, right? So that's it, guys. Structured bindings do really come in handy to iterate over containers, especially in this case where we had a map. It greatly reduces the need to manually unpack the keys and the values in the map. and kind of also makes your code shorter, which is always good. Alright guys, let's wrap up structured bindings. So what are structured bindings? Nothing but a clever way to unpack your elements from your C++ standard containers. So can be pairs, can be tuples, can be maps, right? They also work with structs. The official C++ documentation provides like 3 signatures, and the only difference you see is the way they deal with the expression. You can do an equal to, you can use curly braces, you can use parentheses. The reference qualifier is optional and the attribute qualifier is optional, right? I guess the essentials are the auto, square brackets, your identifier list, and the expression, right? And why did the committee really decide to add this feature? I think the two big reasons were they wanted developers to make their code more expressive and easier to understand. So structured bindings do help with that. And the other big reason is they also help in reducing the lines of code, right? When you're working with big code bases, number of lines of code is a very important matrix. The less code you have, the better it is from a maintainability perspective. So structured bindings do help with that. Alright, I hope you understood structured bindings and can find ways to apply it in real life. And please put your feedback in the comment section. And thank you very much.